Today I'm going to talk about this 5G MEC. I mean, we have like a very good presentation from Sir Benji about edge computing. Focus a little bit more on the IT part. I will be focused on the edge computing, but based on the telecommunication. Okay, first we are going to talk about this multi-axis edge computing. This will be like the general topics I'm going to talk. If talking a bit about introduction, a main concept, what is MEC, why MEC is necessary, MEC and 5G, MEC uses case, the future, final consideration, and some question at the end. First, we have this short introduction. I copied this slide from Red Hat that shows very well how was this evolution from the traditional equipment to the virtual and cloud native that we have so far. So, I mean, before of the time, let's want to say around 2000 and around that time, we work a lot about physical network function. I mean, we have some specific hardware doing some functions for packet, for IMS, for all of these activities, as you can see here. Then, as we go in the time, we start using this virtual application. We start to using like these virtual machines running on the standard computing servers, having like this layer of virtual support, and then all the application working on top of all of that. So we use generic hardware called COTS. We put this virtual layer over there, and then we put all of several applications. This kind of evolution was common or was very like similar for all the core parts, the RAN parts, and also for the transmission that also you were using this virtual evolution or this virtual network function in the network for all the function that we have. And then like in the next step, we have like this cloud native that, I mean, all of these components are going or are using this CNF or these container network functions to deploy like several applications. We can have here like core application. We can have here like RAN application or transmission application or any kind of application, like living for all of this evolution. I mean, we don't need like one specific hardware, proprietary hardware to design like a core. But right now we can deploy all of those functionalities in the cloud. That will be a little bit explained later. Here we can see like this evolution of the cloud. That's going to be interesting to know a little bit. For all, in particular, focus on the core. You have, as we saw in the previous slide, the evolution from traditional using proprietary hardware, the virtualized for all of that hardware, in particular for core, the cloudified that we started using all of these private or public cloud servers, and all of our applications deployed in those cloud environments. So we are somehow here, and we are expecting to have like this evolution there, like let's gonna say this next evolution, like in now, like in the close future, like everything will be cloud native. I mean, we will have all of this deployment starting in clouds. As you know, like this is like the main concept we have right now. Like all the particular components that we have for a wireless network, you know that we have this mobile core with different functionalities inside there. We have also this radio part that also that's transmitting the signal to allow the communication. We have also the user equipment, like all type of equipment here that could be IoT, CPE, MiFi, mobile phone, and all of those devices. And also to allow this wireless network function properly, we need the transport. That could be all the solutions available now, that microwave, satellite, fiber, or whatever. And also, we need the spectrum. We need a spectrum license, no license, with low, medium, high, or whatever, depending on the technology. So to build this network, we need all of this. Why I'm talking about all of this? Because most of the functionalities here, in particular core, transport, and radio, has suffered like this evolution from the physical network to virtual to cloudified. And so we are living right now that it's possible to deploy all of these functionalities on top of a cloud. Essentially, when we talk about edge, I mean, you ask one people from IT part, and he will mention some part. What will be his definition of what will be the core, and and what will be the edge, as mentioned here. They will consider the cloud, whatever is in the data center, and whatever else will be edge, remote edge, or very edge. Depending on the company or the sector, I mean, this definition of what is cloud and what is edge or remote edge will be different from each one of those view. So from our side, that we are focused here on the telco side, we can say that the cloud part correspond to all of these parts that is covering all the data centers. And when we start talking about edge, we start talking about particular will be for this part, including part of the tower, also in the user part, and also in the device. So this one is just to show you a little bit like how many parts will consider what is cloud and what is edge. From our particular part of telecommunication, we're gonna see like this kind of concepts. I mean, we have this cloud computing that is a general concept shared by IT and telco. That is a model to enable to put services in any part on demand, and can be shared like and can be shared for different users. Also, there is another definition that sometimes we use, that is fog computing. Fog computing refers to this intermediate part between the cloud and the origin of the data. And also they have some additional part where they process data and handle or aggregate data in the network. The edge, that is also another common concept between telco and IT. That is like these parts between cloud and the end users without this additional aggregation part. We're gonna see this in the next slide, but this is just to show you a little bit like the main concept. The multi-access edge computing is a particular concept that we are talking in telco and telecommunication. That is essentially edge, or the area that is defined by edge computing, but using the ETSI standard. So here in telecommunication, we have one standard that defines, or that makes the definition for what is edge computing applied to telecommunications. So if in any discussion with anybody, you see that they are talking about MEC, you know for sure that is an ETSI standard, and they are talking about telecommunication. But if they are talking in any context, they are talking about edge computing. If you are talking about IT, could be represent something, and if you are talking about telco, most probably will refers to this standard. And there is also another definition that we sometimes use, that is a cloudlet. Cloud is essentially like a small cloud focused in a small physical area, like for example, a building, a company, or an enterprise, so that they concentrate the process in that cloud, in that small cloud over there, and they don't need to transmit the data to the central cloud. In this slide here, we use again this very nice slide from Red Hat, where we can see like this cloud concepts. So we have here, our core, the data center and the regional data core, and also we have here the edge. So this one, in particular, referring to the core, we are calling this a cloud computing, and when we go for this cloud computing to the edge, including this aggregation layer here in this part, we call this fog computing, FOG computing. The edge computer, they doesn't have like that particular additional area there, like this aggregation area, but we call it just edge computing. And we are, if we refer to the ETSI standard in the telecommunication area, we just call it MEC. Also here, we can see the cloudlet, because you have like this, edge processor or server or cloud server here located like in the edge in the building. And so that's why we call it this part a cloudlet. So here, just to show you like the most important for us now, I mean, like concept is cloud computing here that is located in the core, in the data core area of our network in telecommunication, where we have all of these switches, the packet core part. And the MEC is located from here, from this cloud to the end user. So for us, I mean, just to know, for telecommunication, we will talk just cloud computing and MEC computing. So this is the video.
For some time now, against the tide of centralized cloud computing, one idea keeps coming back. What if we could save data from having to travel thousands of kilometers when it is destined to come back to the same place? This is the idea behind multi-access edge computing. We call it MEC. MEC is like small, local clouds, physically installed as close as possible to the users at a mobile base station, for instance. The content from here is used here and stored here. This sounds obvious. However, it is this geographical proximity that makes it possible to imagine vehicles that transmit information to each other at the speed of light. Or factories lowering their costs by processing their confidential data on site. Or even gamers who can enjoy exceptional speed and great quality of play. Oh, of course, some might say, hey, but all this we already did before. Yes, but never so rapidly and securely. Ah, yes, indeed. Obviously, MEC technologies need to be standardized and therefore made fully interoperable. Hey! This is why, at ETSI, we have been working on standardizing this technology since its inception. All the players who are involved in MEC technology, closely or remotely, participate in the work done by ETSI on an equal footing. So, if you want to be where MEC brings edge computing into reality, join us.
Okay, so in that video, which we saw a little bit like the main concept for the MEC according to the ETSI. This is a very good video to show to see this, what is essentially this MEC. Anyway, below you have like some reference. I mean, you can just look in the internet, just ETSI MEC, and you will find like a very good link for that to see that implementation. As you can see here, it's a ETSI defined network architecture concept that enables cloud computing at the edge of the cellular network, a little bit as we see in the drawing. So here, MEC was evolved to support a wide range of applications and services, particularly with 5G, but also was included, is also considered for 4G. It's a key technology for enable low latency, high bandwidth services at the network edge. Here you have the link. As I mentioned, you can just look in the internet by ETSI Edge, ETSI MEC, and you will find this link. This standard was defined by the ETSI in 2014 by the European Telecommunication Standard Institute. In 2017, they changed the name from what we see here, the mobile edge computing. They changed it to the multi-axis edge computing. They put like this name, or they changed it for this name to allow like all to allow other connection possibilities, not just wireless like 4G or 5G, but also Wi-Fi and wireline connection, like cabling connections. In the 2022, we have like this latest standard or this latest specification for the MEC on their ETSI. So you will see, you can see over there like the general framework about how is it working. Why MEC is necessary? As you see here, is necessary in the 5G network to support like different kind of application. Just let me check, close something here. To allow like a better processing and efficient base bandwidth use. As we can see here, like using this slide, it's not just like general traffic. I mean, we have like different kind of traffic in our networks or in our mobile network. For example, in our phones, we can save our data in the data core. So for this kind of deployment, we don't need like a low latency on this communication. I mean, we don't matter if this is a picture or this data is stored in 1 minute or in 1 hour or in 2 hours. We just need like to store it like sometime. But there are like critical activities, like for example, where you're working in the B2X communication, like for example, in vehicles, when we have like in the future, like this possibility that you need to process like data very fast. I mean, in this case, you don't need, I mean, you cannot wait to put the data for these vehicles here in the core, because you will spend like a lot of time doing that. So you need, in these particular cases, to process the data as close as possible to the end user. That's why essentially you need the MEC for all of these kind of time-sensitive applications where you need to process the data very fast and to take the decision very fast. Because if you wait here, for example, to wait for, I don't know, 2 minutes to store or to process information here and return, you can crash your car. So here you have like this information about, for example, this without edge computing, like in general, like any process, sorry, could could take like a lot of time. I mean, you can have like between 70 and 60 milliseconds to process, because you have to go or to process the data from the device, the base station, to the core internet regional, and to internet global. And I mean, to go from there and to return back all the information and all the process, it would take like a lot of time. That's why you need, for particular cases that we will see later, you will need edge computing, because you can have, using, for example, the 5G networks, like very low processing time, like between 10 or 30 milliseconds from device to base station to edge computer, and then returning like all the process and all the information required. That's why it's necessary like this edge processing to bring all of this capacity, all of this process capacity very close to this user here. So here we see why we need MEC and 5G. The MEC, multi-access edge computing, and 5G networks are a perfect match because they need or they complement to each other. We have, for example, MEC and 5G. We can support like different kind of application and different industry. For example, as we see like this vehicle processing, like for example, as Mr. Benji mentioned on his slide for video processing, that you can process like all of that information like very close to the end user. Also, you need to be very energy efficient, because with this local processing, you can reduce the energy consumption. I mean, you don't need like a big data center to process all the information. You can process your information locally or very close to the end user. Also, you optimize the bandwidth. I mean, you don't need like very large bandwidth between the user and the core, because everything on most of the processing is done locally. Also for the cameras, you can do like most of the processing locally and just go to the core to particular cases, like for example, data storage that is not like so critical to process. Also for IoT enablement, because as mentioned, you can process this kind of the data from IoT like very locally using the MEC, the multi-access edge computing, seamless integration and investment protection, because MEC can be integrated into 4G and 5G, protecting investment and also facilitating all of this application time sensitive, like URLC application or use case for 5G. And also the ultra low latency, because MEC will reduce the data time travel. I mean, you don't need to travel from the user to the core, but you can go like very fast to the MEC. And for that, you can have this ultra low latency and comply with the requirements in 5G that is considered that the target is like the 1 milliseconds. So with this, they can facilitate a lot this objective in the 5G to have ultra low latency communication. This one is the concept, or the main concept we have for the 5G architecture. We have seen a lot the architecture for the radio parts. This one is just to show a little bit like what is the main concept for the architecture in 5G. In 5G, we have something called service-based architecture. We have a lot of these functionalities working together to allow us like this configuration. So these functions are deployed in the cloud, or and they facilitate all of these 5G networks. So we have like these functions working on the control plane, and some functionalities, for example, these user plane functions that are deployed or use the data plane, because are essentially used to allow the communication from this core to the end users. So here, I don't just want to bother you like with all this definition, but particular what we are using here, what we need from this 5G core network is this access mobility management function. Is essentially to allow the end users to be recognized here in the network. We have this session management function. I mean, to allow us, like once the user is identified in this network, they could handle these data sessions. We have these user plane functions in the 5G networks that allows the data communication to the user equipment. As you can see here, this user data plane is essentially the main communication, or the main communication from the core to the user equipment, and also where we need to use this access and mobility to the end user. So essentially for the connection of the user equipment, we use this access, mobility, and management function, and we are using this user plane function here. And for all of this, there is also like a very important concept for us that is being used, or at least is being evaluated by different operators, is this network data analytic function called NWDAF. That is a component introduced in the 5G network to allow us the data processing. I mean, because as you know, in all of these functions, they are processing, or they are handling like a lot of information. So this element here, the network data analytics, they take the data or information from all of this, and also using this data from here, they can add this, and also using the artificial intelligence and machine learning, they can take decision and take and use that information for different kind of activity. For example, for location. I mean, they can take information from the device, what kind of data is processing, and combine with external information. They can use artificial intelligence to provide this information to external entities, for example, application like, for example, like Uber or whatever application for location, and to be consumed or to be used by third parties. So we have here, like the main conclusion of this slide is in 5G network, we have different functions that allow us to work, and one particular function that is focused on artificial intelligence and machine learning, that is this one called network data analytic functions. So why is important to know all of this? Because we also have this MEC functionality working on this. This is like the main definition of the MEC defined by the ETSI. You have here the link. As mentioned, is write ETSI, MEC, and 5G, and you will find like this document where they define all of this architecture for the MEC. They mention, for example, the orchestrator that allow us to create like all of these or to handle all of these MEC components, all of these applications that will be working on this MEC ecosystem. This virtualization infrastructure, because as you know, this MEC is also working on the cloud. And so with this MEC is also possible to have like this kind of integration. So when we talk about 5G and MEC, this is how it looks. I mean, you have like most of the network function working on the main 5G cores, and some basic function, like for example, user plane functionalities working on the MEC. Why is this useful? Because you will have like this MEC ecosystem very close to the RAN site and also to the user equipment, and so allow us to process this data like very fast. I mean, you will process this data connection here like very fast because it's located in the MEC. So to see like how is deployed like this MEC architecture, we can see like in this drawing here, you have that the MEC can be deployed in different locations very close to the base station. Like part of the processing will go as fast, as close as possible to the end user, as we can see here on this slide. So we have, for example, this kind of configuration when we have like this, where we have this user plane functionalities here located in the close to the base station. Also, we have like this configuration that is located in this transmission node, like this MEC with the user functionalities here located very close to the transmission node. Also, we have here the MEC with the user plane functionalities close to this aggregation point in the transmission area. And also there is like another point that is co-located here to the core, because there are some particular occasions where you can have like this MEC close to the core, and also and so these are like the four main deployment options defined by the ETSI. So you have here close to the site, close in this transmission node, co-located in a network aggregation point for transmission, and close to the core. Depending on the configuration or depending on the needs, you will have like these different options to deploy your MEC. So here you have like the MEC use case. So here, as we see, like the two main cases is third-party cloud for MEC in 5G environment. So on this area, as you can see, we have like this core, and we have also this MEC located in the cloud, working for a third party. So this one opens like possibilities, because the MEC could be also deployed or could be also used by third parties. So this one is one of the options, and this one is host with or without break out to the cloud, like we have here, like the MEC host, where, for example, in the case of IoT, you can process all of these functionality, or you can process all of that information locally. So you have here your end user, and you have here this MEC, for example, in a building. And so in this building, you have these basic functionalities located here with all of your application located also here, like this MEC app. And so you don't need to go to the core. I mean, you process all your information in this area also without even going to the main cloud in the capital. For example, in the capital of the city, you process all of that in your building. And there is other one that you process your information. I mean, you have this application here that could be, for example, like IoT processing data and all of that. But in this particular case, you go to the cloud because you need to get information from the cloud. For example, additional information about, I don't know, like additional data to complement your IoT. So you have here like these three main cases where you have the core and the MEC platform deployed to support that core. That is something like the typical, one of the typical configurations. And you have these options where you process everything locally here. And the other one is you process locally, but you need some access, or you need some access to the cloud, to some particular applications. So for when we talk about particular use case, a little bit of what mentioned with Mr. Benji is there are several applications that could use a lot of this MEC processing. Do not go to the core to process everything to the core, but to take advantage of the MEC to support your application. For example, like augmented reality, as mentioned here, augmented reality and also virtual reality, that if you process everything locally, you don't consume like so much throughput, I mean, connecting to the core, and also you can get like a very fast answer here. The other one is for data catching. I mean, you have like a lot of your data here, and when you have, for example, your phone, you don't need to go also to the cloud, to the main core, to the main cloud. You can data catching or data upload all of your information in this MEC to local storage of content of this. For example, this one is very useful for like companies or for that wants to protect the data, or the data is very sensitive, like for example, medical reports and all of that, that you just want to collect that data locally. And for a core connection, you just do it for just particular cases. Another application, mobile application that is very useful to use this MEC configuration is the Internet of Things. Because for this Internet of Things, you can process all of this data, also for real time and all of that, and you can handle most of this operation locally. You don't need to go to like a central place. You can process all of that to locally in the MEC cloud, and maybe in the core, you just store some data, some particular data, like historical data, like from the month and all of that. But for real-time application, like for example, vehicles, sensing vehicles and all of that, you process locally. I mean, you locally in the MEC, and you take decisions locally and very fast. And as mentioned, in the core, you just process or you just store like a monthly statistic or very particular information over there. Also for location services, it's very useful to use these MEC processes and also to take decision over there for data optimized local content distribution, a little bit like the CDN mentioned by Mr. Benji, that you can have like these local distribution areas where you can store like some content, like for example, the most famous movies like in the Times. And so you don't need to go to the core, but you can you can get that information locally from the edge, and that edge could be MEC, sorry, could be located very close. I mean, in the country or also in the particular state or district where you are living. As mentioned, also the V2X communication, they take advantage a lot of this MEC processing. And also, what was mentioned a little bit, it is about the video analytics. That when you have like these capabilities, these data processing capabilities, like local in this MEC, you can have like very fast. You can take like very fast decision and just use the core to some storage data from the day or from the month, but locally you can take it like very. You can take this decision in a very short period of time, like very fast decisions. These slides is not, let's gonna say, it's not like official from MEC, but they are talking about edge cloud computing numbers. It's from the ETNO. ETNO is a European telecommunication network operators. It's a consortium of European operators, and they generate these reports. I mean, in the internet, you can just look at like ETNO report 2024. They just make this report in 2000 in this January, and they show like what is the general number for edge cloud computing. They don't, as mentioned, edge cloud computing is a concept that involves compute and storage in the edge. MEC is like the edge cloud computing, but standardized by the ETSI. So officially, these are not numbers from the MEC because it's not a specific, it's not mentioned here directly here, but we can assume that these one are referring to MEC because they mentioned here edge cloud computing, and they are mentioning here European telecommunication network operators. So we can assume this, I mean, assume this like is for MEC, but it's not specifically mentioned here. But for our case, I think it is show us a little bit some numbers that could be interesting for us. So for these edge cloud offers by global region in 2023, they are mentioned like all of this number. For example, the Asian Pacific, this number for announcement and commercial available right now, I mean, right now in 2023, in North America, we have like this number. In the countries that belong to the this organization, to the ETNO, they are talking about 13 announcement and 4 commercial, and for Europe, I mean, for all the countries not belonging to the ETNO, they are talking about 8 announcement and 4 already commercial, and the rest of the world, they are mentioning about 4 announcement and 1 commercial. This is just to provide like some numbers about what is going on for edge cloud offers in the world. I mean, from the Asia with these numbers here, North America here, and the rest of the world. Just to mention, like, what are the numbers do we have so far about edge cloud offers around the world? And this one is what are the enterprise spending on public edge computing services by region worldwide between 2019 and 2026. So as we see here, we have the numbers we have for real numbers. I mean, they are talking, for example, in 2022 for around 15,000 million US dollars spent on public edge computing services. For 2023, this is forecast because they still don't have like the final numbers, but they are expecting to have 20,000 million US dollars. And for North America, these are the numbers. Latin America, like this one, and also we have like the other regions with all of these details. So they are expecting to have in forecast for 2026 like around 35,000 million US dollar spent on this edge cloud deployment. So with this two figures from the end. They are referring to edge cloud computing. We can see from one side what are the, let's say, the operators working on edge cloud offers in around the world. And the second, and this slide here, and this drawing here is what are they expected to spend in enterprise public edge computing services. So what is the expected future for MEC? As you know, MEC are starting to deploy now in different operators around the world, as mentioned in the previous slide. In 5G, there are some particular application for 4G, but particular focus on 5G. So considering the MEC, the future of MEC for 5G networks and the 6G networks, this is what is expected for all of them. One is expected the usage for advanced use case to support sophisticated 5G and future 5G applications, for example, including intelligent video, AR, and all augmented reality, virtual reality, and all of those reality applications, the V2X application, all of these vehicle application communication that are really necessary, like this very fast processing. So the development of this V2X are focused a lot on this edge MEC development. The other one is the cost configuration, the cost consideration to optimize all of this MEC development, to optimize this in terms of cost, because as you know, it's one additional component that you are including in the network. So the main topic about cost is about how to optimize the investment considering the MEC, to deploy a proper MEC that is cost optimized, and also that optimize all of these use cases that we have seen in the previous slide. We are also seeing like this energy efficiency and sustainability. Like future MEC deployments will focus a lot on reducing energy consumptions and aligning with these global goals. Enhance in standards and specification. I mean, the future of all of this MEC is to continuously evolve. It's not just to keep with what they have now, but is to focus, to focus on developing new application or new usage that could be necessary for all the user. Integration with 5G and beyond. All of this integration between MEC and artificial intelligence, integration with AI, for more efficient edge data processing, a little bit what we were seeing in the networking data analytic functions that incorporates all of these functionality or possibilities of AI, artificial intelligence with MEC to get the best from the network. Ubiquitous network and computing is MEC will become more widespread, supporting technical and service innovation and the network edge. I mean, with all of this innovation and all of this approach to going very close to the MEC users, there are also developers now working on very compact core device. I mean, like in a very small box, to have core functionalities over there and also MEC functionalities over there. So with all of this network evolution, we could have like very close in the very close future, these small boxes with these MEC functionalities that could be also incorporated like very easily in our radio base, or also close to the end user. So it's possible that like to have like this network and computing like everywhere using these MEC principles. So with this, I think we can finish that presentation with this final consideration. The multi-access edge computing, known like mobile edge computing, like an ETSI defined network, changed the name with a multi-access edge computing. MEC is very important component in the evolution of 5G and 5G network. As we see a little bit with the application shown below, before, it offers advantage in terms of latency, bandwidth, and energy efficient, because you don't need to go to the core. You can process things very close to the end users. It's important. It's important because will support like several or will help a lot of applications, making a critical component in future telecommunication infrastructure. So, however, as mentioned by Mr. Benji before, Sir Benji, sorry, there are challenges such as cost, complexity, power efficiency, and several components, several aspects that should be evaluated, that are challenges, but anyway, something that could be solved with all of this network evolution. And here are two references that we can see about this this technology, the multi-access edge computer. There is the ETSI. You just look for the internet ETSI, a multi-edge MEC, and they will direct you to this link, and also to the 3GPP. These, I think, these are like the two main links right now for this concept. Anyway, like all of the main providers like Nokia, Ericsson, Huawei, CTE, Samsung, all of that, they have this multi-access edge computing pages with their own content and with their own information they have for this. So if you are interested to know more about this, I invite you to visit those main providers and check this MEC, because for sure they have very interesting information.